melodramatic. If you believe the people who like travel services, who have a preference for travel services, are also people who use their cards more, then you're going to want to offer more travel services, right? And so the key quantities that we're going to need are going to be pretty similar to the ones we had before. The number of people along the margin, the market power, the average marginal utility of a marginal person and of an average person, and now the average value of the characteristic for someone who's on the margin. But there's going to be a key new quantity, which is going to be the covariance between preferences, and I'll be more precise about what I mean, and contributions that people make along the margin. Okay, so to be more precise, Colin Lucas? No? Jesus Christ, this can't possibly be that nobody's here. Everyone's just laying low. You're a bunch of cowards. Okay, so
I think they're not here. I don't think anyone's cheating.
Really?
Yeah.
I have like a list of, how could I possibly, by randomly choosing from a list of people that are in this class, always choose people who aren't in the class?
There's like 75 people in the class.
And only like 30 people show up to any given lecture.
That's pretty awful.
I say I have to get an updated list or something. Okay, so what I mean by this is let's call sigma the covariance along the set of people who are marginal, who are indifferent between consuming and not, whose utility is equal to the price, between the marginal utility that they get and their value of the characteristic. That's what I mean by covariance between preference and contribution. Right? And then we can just chug along with the math we were using before. So when I increase n, how much does that change the price? Well, it changes the price by 1 over m times the marginal utility of the average marginal person times how much changing the number of people changes the total amount of the characteristic. Right? Then, how much does changing the number of people change the characteristic? Well, it reduces it by the number of people along the margin times their average value times however much the price has to rise when the number increases, or however much the price changes when the number increases. He's going to increase it by the number of people along the margin times, and this just comes out of Leibniz's rule, right? The marginal utility of people times their contribution, the average value of that, times how much changing the number of people changes the characteristic. Because if changing the number of people changes the characteristic, right, then that's going to attract people proportional to their marginal utilities, and they're going to contribute the amount of the characteristic. So this is basically, it's going to select in the people who value it the most. So that just comes out of applying Leibniz's rule to this equation. If it changes the total amount of the characteristic, we get u prime times k along the boundary. Right? Andre?
The big tilde is just the two things with tilde multiplied?
No, it's the average value along the margin of the product of these two things. That's going to be crucial. It's not each thing tilde, it's the average value of the product of those two things along the margin. But that's how we're going to get our covariance. Okay. So, notice how we're going to solve this, right? This should be pretty simple. We can now bring this over to the other side and divide through, and then we just need to figure out what dpdn is, right? Okay. Well, we know that dpdn is just this expression here, right? So we can substitute this dpdn into this expression, right? And what do we get? We get that dkdn is equal to k tilde, because you get that out of the negative 1 over m there, right? Times m times the difference between this tilde u prime k and u prime tilde times k tilde. But what's that? Well, you know from your econometrics class, right, that the expectation of a product minus the product of the expectations is the covariance, right? And then we multiply that by dkdn, and so we can just replace this thing in here with sigma from above, right? And then we get dkdn is equal to k tilde plus m times sigma times dkdn. Bring that over to the other side, and we get dkdn is equal to k tilde times 1 minus, divided by 1 minus m times sigma. And then we can substitute in, we get dpdn is equal to negative 1 over m times k tilde u tilde prime over 1 minus m sigma. And the basic intuition of this is that if sigma is positive, bringing in more people, which brings in more of the characteristic, then attracts and sorts for more people of that type. More people with higher characteristics if sigma is positive. And let me see. An example of that might be, you could think of the telephone network. You can imagine there being two different ways in which people along the margin can get it. It could be that there's the popular kids and the losers along the margin, so that the popular kids are going to most value using the phone, or having more people use the phone, because they talk to a lot of people, but they're also going to be the best people that everybody else is going to want to get on the phone, right? Whereas the losers are going to be low on both of those things. Then sigma will be positive. On the other hand, imagine that it's telemarketers versus grannies that are the people. Well, then the people most value getting on the phone are going to be the granny, but she's not going to want to use the phone very much, and she's not going to value very much having other people use the phone. But the telemarketers are going to be the ones who value most people using the phone, but they're going to be the ones people least want on the network, right? And so that's going to determine whether sigma is positive or negative, whether bringing in more people sorts for better people or for worse people. And therefore, whether this thing is self-reinforcing, in which case it blows up the value of that expression, or whether it's self-defeating, in which it reduces. And the point is, this is sort of like an infinite series, right? Because it's like you bring in more of the characteristic, that sorts for people, that brings in more of the characteristic, that sorts for people, and so forth. And that's why you get this 1 over 1 minus that, because that comes out of an infinite series. And so what we just get is that the social value, the derivative of the social value is again price minus cost times however much the characteristic is changing, and that value for all the inframarginal guys, so you just get this expression here. And the derivative of profits with respect to the number of people is going to be price minus the Cournot distortion minus marginal cost times the expression for the average marginal person. And this gives you very simple optimal pricing rules. So the subsidy that you give, the amount that price is below marginal cost, in the social planners is equal to the average characteristic of the marginal guys times the direct externality they bring divided by 1 minus this sorting effect, right? So it's multiplied up by this multiply. And the private optimum is that the discount you give below the point where marginal revenue equals marginal cost is equal to, again, the value of this average characteristic times the value that the marginal guys get multiplied up by this multiplier. So the spent distortion can either be mitigated if this is negative or magnified if this is positive by this additional effect. And notice that if these two dimensions, if the preferences and the contributions are not correlated with one another, this whole multiplier goes away, and you just get back to the simple formula, except that you have the average value of the marginal value. So the key feature here is not that there's heterogeneity in people's contributions. It's that there's heterogeneity in people's contributions, which is correlated with their preferences. So the key is not heterogeneity of contributions, but covariance between contributions and preferences. Okay. So a very nice application of this was given by Einov et al. 2011, which shows how this logic applies outside of the platform context. It's really relevant whenever there are different consumers who bring different value to the firm. So one example of this is subprime auto loans to diverse consumers. So some consumers are better credit risks than others are, and there are different product dimensions that you can use to try to get the good consumers and get rid of the bad ones. One is the down payment that you ask for, another is the interest rate, the sticker price of the car, lots of things like this. And people have observable credit scores, but that's definitely not a sufficient statistic for their risk profile. And changing the required down payment can affect the chance that someone repays you in two ways. First, it just directly reduces the chances that someone defaults because it reduces the amount of debt they have to take on for the car, right? But, and this is going to be just like lots of other incentive problems that we'll deal with throughout the course. But what I'm more interested in talking about now is that cash-strapped borrowers are less likely to repay you, and they're also less likely to be able to make a large down payment, right? So by having a higher down payment, you select for people who are more likely to repay and are better credit risks, right? And Einov et al. Look at this, and the way they do it is they look at times when this company they got data from changed the down payment requirements, and they use a regression discontinuity design, assuming that there wasn't any abrupt change around that, seeing what the effect that had on who came in. And the interesting thing, actually, is that charging a higher sticker price, even if you don't alienate anyone, can be counterproductive, because it actually has a sorting effect. Because the people who are least likely to actually make all the rest of the payments care least about what the sticker price is, right? Okay. So here's just what they got. So they found that as you increase the minimum down payment, you greatly reduce the chance that you make a sale, but you also reduce the default probability. And that means that actually the expected profit might actually increase over quite a bit of the range as you increase the minimum down payment, even though you reduce the chance, the number of sales you make.
Is that diamond the optimum point? Is that not the black diamond?
Yeah, I think, yeah, it's the
So
problem.
it's basically the same as if they charge a down payment that's, close to twice as much.
Yeah, so that turns out to be the right point. I don't know why that's.
I mean, they pick a down payment really anywhere from there and up.
Yeah.
To the right of that, and you get the
Yeah.
same.
That's just how it turns out. Okay, so this is I gave one example here, but there's lots of other examples. Matt Ark. No. Okay, so we're going to just go through a bunch of other examples. Optimal political slant, like we were talking about the Jenskow-Shapiro model. If richer people are also more right-wing, that's going to give you an incentive to make your paper more right-wing than the average person in the area would want you to do, right? Because those people may be better for advertisers. Soap operas appeal to John Milton. Credit cards, points. Credit cards often use points, and one reason they do that, rather than just giving you like a subsidy for taking the card, is because that rewards people who are likely to use the card most, right? So those are the people you want to get into using your card. So it both encourages people to use the card more, but it also attracts to the thing people who are likely to use the card often. And that's one reason that some cards have an annual fee, but a lot of points, because that's going to attract only the people who plan to use the card a lot. And travel benefits work in a similar way. Another case where there's sort of a whole hierarchy of sorting effects going on is that a lot of clubs will sort of like bring in rock stars because that attracts a lot of beautiful women, and the beautiful women attract a lot of rich men, and the rich men pay for a lot of drinks, and that makes the club money, right? So that's like a multi-layered platform effect where you use an instrument, the rock stars, to attract